All right, guys. This video gets into marginal means plots and how we look at plots and of the marginal means, and how we look at the table of marginal means to make pretty important decisions. What I'm going to do here is just create kind of a fictional education scenario. So let's say that we are looking at ACT math scores across a group of students at a large school district, and we are looking at these ACT scores across their gender, obviously male or female, and we also want to look across the teacher's gender. So we're assuming, I guess, that however many classes these students have taken at the high school level, that they've had those classes under the same teacher. And guys, don't take this stuff too seriously. I don't even know how it's going to turn out, because I'm going to make the numbers up as I go to create certain scenarios. So don't run out if it happens just to be that female students get better grades than male teacher. Don't go out and say, well, Dr. Darbo said that. I'm making this stuff up. Okay, I'm making it up to to just provide illustrations of different scenarios. All right, so a couple of assumptions here that we're going to make. And first of all, the big assumption is that a 2-point difference is statistically significant. Okay? The other assumption is that we are going to run a two-way ANOVA to examine ACT scores across students, gender, and teacher's gender. So we are interested in the main effects. Is there a difference in the mean ACT scores across gender? So this is across students' gender. And is there a difference in mean ACT scores across the teacher's gender? We are also interested in the interaction effect. For example, is there any indication whatsoever that male teachers are more successful with male students, or female students, or female instructors, or teachers seem to have students do better of one gender of the other in their class? Okay, so that's what we're going to look at, and I'm going to give you some scenarios of when we have statistical significance of main effects and interaction effects. We'll look at the marginal mean plots, and we'll try to make some generalizations and conclusions from these examples. Okay. Now, the first scenario that I want to give you, and I'm going to use this stuff over and over. So what I want to do here is I want to put the students' gender here, and then I'm going to create my marginals to make a point. And then here I want the teacher. And we'll put the marginals Well, I don't know why, but my pen will not right down there, but I can write it with my finger, but it's really ugly. Okay, so that's what we're getting into. Okay, now for each of these, I want to create the marginal means plot. And I'm going to do that over the students' gender. And I don't know. What are we going to do here? Let's go in with a blue. For male teacher. And let's go with, say, a yellow for a female teacher. So we'll do this consistently, and then we'll make some generalizations about what we've got going on here, and that's just driving me crazy down here. So that's just too ugly. So let's go back to white, and this is for the student. And our means are going to run anywhere from 20, 22, 24, 26, and let's say 28. All right? You guys with me? Hopefully you are. Okay. Now let's go back here and let's look at a situation where we have nothing that's statistically significant. And that would be in a situation where we had all of our means ACTs of 24. So for the male teachers, his students averaged 24. For the female teachers, their students averaged 24. Examining the means across students, the male students had an average of 24, and the female students had an average of 24. So in this situation, again, going back to, very important, again, let me point this out. One of the assumptions, 2-point difference, statistically significant. So we don't have any statistical significance here in the teacher or across student. Moreover, we have no indication of a difference of statistical significance breaking down gender of the teacher and gender of the student. Now, if we got something like this, our interaction plot is going to have a blue line from 24 over to males of 24. And it's going to have a yellow line drawn right on top of that. So that's a situation where we would have neither the main effects statistically significant or the interactions. Okay? Now let's look at the second situation. Now this situation, let's go with the following scenario. Let's say that we have 22, 22, and 26, and 26. So the marginal means here for the male teacher has an average of 22. For the female teacher has an average of 26. but the male students had an average of 24 and the female students had an average of 24. So there's no statistically significant difference across gender, but there is a statistically significant difference across the gender of the teacher. So female teachers in this situation seem to be doing a better job of teaching, if you buy into that whole ACT being representative of learning, which it's representative of something. I just haven't yet figured out what it is. But there's a difference. Now, in this situation, what do we have? We have the gender of the teacher being statistically significant, again with evidence that the male or female teachers are experiencing more success. Now, what's going to happen over here is going to be quite interesting. Our blue line is representing the male teacher, and that was going from 22 to 22. And the female teacher, which would be the yellow, would be from 26 to 26. Now, when we examine just the picture alone and don't look at the marginal means plot, what happens is we can look at the average of the lines. So across gender, we have a difference of 2 units. That is, across gender of the teacher, a difference of 2 units each, so we have statistical significance. However, the average of this line right here is 26. The average of this line right here is 22. Showing us again more of a difference of more than 2 units between the male and the female teachers. But when we look at the difference across males and females, there's a difference over here of 4 units, and there's a difference over here of 4 units, and 4 is not 4 units away from 4. I'm sorry, 4 is not more than 2 units away, which gives statistical significance. So we don't have statistical significance across the gender of the student. Hope that made sense. This is not rocket science yet. We're going to get into some more sophisticated stuff, but not yet. Alrighty, let's get rid of all this stuff. And now what I want to do is I want to create a situation where we have the main effect of the gender of the student to be statistically significant. And I think I can put a 26 there and a 22 there, and a 26 there and a 22 there. So the marginal mean would be 24 and 24, so no statistically significant difference across the gender of the teacher. But here we have a 4-unit difference across the gender of the student from 26 to 22, so we have a statistically significant main effect for the gender of the student. Now, what's the marginal mean plot going to look like over here? Well, if we come to the blue line, the blue line represents the male teacher, which is going to go from 26 to 22. Okay, and then we're going to have the yellow line, which is also going to go from 26 to 22. So now if we look at, examine the difference between, let me go back to the white pen so we don't get it. If we look at the difference between across gender, we can see that we have an average of 26 over here, and an average of 22 over here, more than a 2-point difference, so we have more of a we have statistically significant across gender of the student. However, take the mean of the yellow line, the mean of the blue line, we get 24 in both situations, so the effect of the gender of the teacher is not statistically significant. All right, let's go to illustration number 4. And illustration number 4 is going to be a situation where we have both main effects are statistically significant. Now, we haven't got into any interaction statistically significant yet, so let's go back and think about it. Illustration number 1, we had nothing statistically significant. Illustration number 2, we had the teacher gender statistically significant. Illustration number 3, we had that the student gender was statistically significant. Well, what if we have a statistical significance between both main effects? And let me see if I can be really creative here and make this happen. I think if we put a 24-20 there and a 28-24 there, that will do the trick. All right, so across gender, we have gender of the teacher. We have 22 and 26. More than a 2-point difference, so we have statistical significance across the gender of the teacher. And here we have 26 and 22. Again, statistical significance across gender of the student. However, if we come in and examine the difference of the interaction, notice there was a -4 change from male to female, and there was a -4 change. This is the change in interaction. So -4 and -4 are not more than 2 units away, so the interaction is not statistically significant. Now, if we get into the marginal mean plots here and come to blue, then for the male teacher, we're going from 24 to 20. And for the female teachers, we're going from 28 to 24. Now, in isolation of the marginal means table, how could we look at this and see that we have a situation where both effects are statistically significant? Well, the average from here to here is 26. The average from here to here is 22. So we have a difference. The average of the yellow line is 26. The average of the blue line is 22. More than 2-point difference. Compare this way for the main effects. I hope this is making sense. This is not rocket science by any stretch of the imagination, but I tell you what, these things can drive you completely insane when they get more sophisticated. You get into power and effect size issues that we'll talk about. So let's come into number 5. And what I'm going to try to illustrate here is a situation where we have the interaction statistically significant, but the main effects are not statistically significant. So again, what I'm trying to do here is create situation number 5, where we would have an interaction with a p-value less than 0.05, but the main effects would have p-values greater than 0.05. Now, what I'd want to do here, this is going to take a little bit more work. Let's go 22, 26. That's going to give me a marginal mean of 24. And let's go 26, 22. Gives me a marginal mean of 24. Marginal mean of 24. Marginal mean of 24. So my gender of the teacher is not statistically significant. the gender of the student is not statistically significant, but I have a positive 4-point difference from male to female for students, for male teachers, and I have a -4 difference for female teachers. So I've got an interaction that's statistically significant. In other words, male students are doing much better in the female teacher's class, and females are doing much better in the male's class. Okay? Now, what would the interaction look like here? Well, when you get a marginal means plot that has a statistically significant interaction effect, your lines are not going to be parallel. They're going to cross. So if we look at what we get here, let's go to our blue line. So this is going to be for the male teacher. So the male teacher was what, from 22 to 26? And go to the yellow line for the female teacher, and that was from 26 to 22. So we have lines that cross, therefore we know that we have a statistically significant interaction, but when we examine the means of males, we get 24. Means across females, 24, so no statistically significant statistically significant difference across gender of the student. Take the mean of the yellow line, we get 24. Take the mean of the blue line, we get 24. So there's no statistically significant difference across the gender of the teacher. Having fun yet, boys and girls? Tell you what's going to be fun is me trying to figure out examples for the ones coming up. We'll be fine. Okay. Now what I'd like to be able to do here is I want to create a situation where the interaction is statistically significant, and I want to create it where the gender of the teacher is statistically significant. So what are we going to do here? Let's do 2028. Going to need some extremes here. And let's go 24, 24. I think this will happen. This is 22. This is, what, 26. So perfect. We have statistical significance between the gender of the teacher, but the gender of the student, there's no statistical significance. When we look at the interaction, we have students, female students doing, approximately 4 points better in the male teacher, whereas female students do 4 points lower. So comparing +4 and -4, more than a 2-point difference. So we have a statistically significant interaction effect along with a statistically significant main effect of the gender of the teacher. Now what will happen here when we get into, so the blue line is going to look like from 20 to 24. And then the yellow line is going to look like 28 to 24. So the in isolation of everything else, again, let's assume that we don't have this over here, and we're just looking at these plots, or at this plot. How do we know? Well, first of all, we know that the interaction, let's just call it A cross B, the interaction effect is statistically significant because we don't have parallel lines. Okay? Now, how do we know which main effect is statistically significant? If I look at the difference here, I go from 20 to 28, which has a mean of 24. If I look at the difference over here, I have 24 plus 24 divided by 2 is 24. So I have no statistical significance from male to female, gender of the student. However, if I take the mean of the yellow line, I get 26. If I take the mean of the blue line, I get 22. So I have more than a 2-point difference, which means I have statistical significance across the gender of the teacher. You guys are just dying to run out and get a PhD in marginal mean plots now, right? Maybe not. All right, boys and girls, let's look at the 7th example, and you probably know where I'm headed with this. If I can pull it off. What I want to create here is a situation where I have a statistically significant interaction. Yeah, this is going to be really easy though. And the interaction effect is statistically significant. The gender of the teacher is not, but the gender of the student is. So we can do something probably 24 and 24. It's going to be really easy. 28 and 20. So we've got 24 and 24. We've got 26 and 22. So guys, more than a 2-point difference. So we have statistical significance across the gender of the student, but clearly we don't have statistical significance across the gender of the teacher. However, when we look at the difference from left to right, we see that for male teachers there's no difference in male and female students, but for female teachers, the male students are doing statistically significant better than the female. So this is a place where the interaction effect would completely override and be very important for us to examine. So the difference that we see down here is not attributed to male-female. It's attributed to the fact that male students are doing a lot better in the classes taught by a female than females are doing in classes that are taught by female. Okay, female students that are taught in classes by female teachers. So this main effect down here of this 26 and 22 that I'm trying to highlight pretty much is irrelevant, because this difference is completely due to that interaction. So gang, what we would get here is our blue line, which is going to be the male teacher. Goes from 24 to 24. And the yellow line, which is the female teacher, goes from 28 to 20. I'll try my best to do that. I think it's going to be pretty close. So again, examining that in isolation of everything else, how do we know what's going on? Well, first of all, the lines cross. So our interaction, and we'll just call it A and B, is statistically significant, which means that we need to examine more closely the marginal means across the gender of the teacher and the gender of the student. Now, how do we know that of the main effects? Well, when we look at the mean here, we get 26. We look at the mean here, we get 22 across gender of the student. So, well, I don't know why in the world I wrote 24 and said 22, but that's just life, okay? So for gender, we have a statistically significant difference, but if you look at the mean of the yellow line, it's 24. The mean of the blue line is 24. So there's no statistically significant difference across the interaction, or I'm sorry, across the gender of the teacher. Now we're going to get really fun, if I can pull this one off. Let's come in and look at a situation where both main effects are statistically significant. I love this little eraser thing. It's just too cool. Yeah, I do have a life, promise you. And see what happens when we have statistical significance for all. Okay, so let's go 2020 and 2820. So we have a mean of 20 and a mean of 24. So we have statistical significance across the gender of the teacher. And we have 24 and 20. So we have statistical significance across the gender of the student. Students do equally well in the class taught by male teachers, but in female teachers, the male students are doing a lot better than the female students. Okay? Now the marginal mean plots for this is going to look like this. So the blue line is going to go from 20 to 20. And the yellow line is going to go from 28 to 20. Now when we look at that, we see that the lines are not parallel, so the interaction effect is statistically significant. If factor A is the gender of the student, well, we have a mean here of 24. We have a mean over here of 20, so we have a statistically significant main effect of the gender of the student. The mean of the yellow line is 24. The mean of the blue line is 20, so we have a statistically significant main effect of the gender of the teacher. So here's a situation where we have all three. Now, when we have all three here, what we typically do is we examine the interaction effect first. This kind of trumps everything else. And it really helps to be able to go back to the marginal means or the cell means. And as we talked about earlier, this mean difference and this mean difference is overwhelmingly created by that difference of male students doing so much better in the classes taught by the female teacher than the female students. So if I were writing this up, I would kind of ignore the main effects and put kind of total attention there. Now, is there ever a situation where the interaction and the main effects need attention? I think so. I think this is going to give you just a quick glimpse of okay, I may have to play around with this one a little bit. Let's yeah, let's take a look at this. Now, what we see here is we have statistical significance across gender of the teacher, statistical significance across gender of the student, and statistical significance significance across the interaction. Because of the big difference, this is 6 units difference, and this is only 2. So this is kind of marginally statistically significant. This is strong evidence against the null. This would be a situation where, because the 2 and the 6 are more than 2 units away from each other, this would be a situation where I think the main effect would be interesting to look at. So what I would want to look at here is, first of all, this is always going to trump. The interaction effect here is what you look at first, and we have statistical significance, and we see why, clearly. Male students are just doing better in the female taught class than female students. But there's also something going on here because of the big difference of the differences. So it's kind of the difference of the differences. There's clearly a main effect here between the gender of the teacher that would be worth examining. And you can draw this out. It's not going to be anything too crazy. So now, you got to remember, in theory, what we're talking about here is we're talking about the population means. And sometimes sample data doesn't always come out like it should. In fact, in the previous video, I was kind of shocked at what I saw. Just things to think about. If you have lines that aren't parallel or overlapping, then this usually means that your interaction effect is statistically significant. Not always true. There's going to be times that we're going to get situations where we may have interaction plots that look like this, yet the p-value for the interaction term is going to be greater than 0.05. And what happens if we get low cell counts? We're going to get into a situation where we don't have adequate power. So we're going to have to investigate this power and what we call Cohen's effect size a little more. But anyway, the next video, I'm going to go through a complete illustration of a two-way ANOVA and tell you things to think about and so on and so forth. So guys, remember what we're doing here. This class is just trying to kind of get you ready to think like an education researcher. We're gonna, you guys are gonna, I think if we keep it right now, I think we have 8 students. If all 8 of you hang with me, I'm probably going to divide you into 2 groups of 4, and you guys are going to do your group research project, and we're going to come up with, some sort of study that's geared toward learning more about teaching and learning in mathematics, and hopefully something geared toward improving instruction in mathematics. So keep that in mind here. This is not a terminal class. This is the beginning of your research sequence. Okay, so what I intend to do, I want you to have a pretty good understanding of ANOVA, and we've we're getting into two-way ANOVA now. I may briefly talk about a 3-way ANOVA. I may give you an illustration on it. But ultimately what we'll get into is called an ANCOVA. And an ANCOVA is just an ANOVA model with a covariate. Now let me give you an illustration where a covariate might be interesting. Let's go back to this illustration right here, and someone says, yeah, you know what, this is all fine and dandy. Male students are doing better in the female teacher's class than their female students. But I happen to know the group of students that this female teacher is getting, and these guys are just smarter anyway. She just happened to get a bunch of smart guys in her class. So what we may want to do is we may want to come in and control for some sort of entering achievement level, some sort of entering academic level understanding of mathematics. Well, that's what we call a covariate. A covariate is what we come in and control for that may be expressing the variation or some of the variance in the measurement that we're interested in. So it may not be the gender of the teacher as much as it is. Maybe she just lucked up and got a bunch of really smart students just because maybe scheduling or something like that. So if you thought that was an issue, you'd want to go in and control for that. And you know, ANOVA allows us to do that. Now, let's say that we get into something where we have two dependent variables. So we have ACT, but we also have students taking the SAT as well. But we still have gender of the student, and we have gender of the teacher. Since we have two dependent variables in here, we're going to get into what's called a ANOVA design. And a ANOVA is just a multiple analysis of variance. We implement ANOVA designs when we have two dependent variables that are highly correlated. Now, if we've got two dependent variables like ACT and maybe, yeah, who knows, let's say IQ, and we run analysis on IQ and ACT and we find no correlation, then we could run two ANOVAs. But if we get in a situation where we have two measurements that are highly correlated, we have to control for that relationship and run what's called a ANOVA. Now, probably know where this is headed. A Marginal design. What if we feel like, again, that this female teacher just happened to end up with better students, and we want to control for that in looking at the effect of ACT and SAT. So guys, that's where we're headed, going through some ANOVA, ANOVA, and Marginal designs. It's going to be kind of cool because I haven't done ANOVAs and Marginals for probably 10 years, so I'm going to have to do some studying, get the notes out. So, all right, guys, that's it. I'm rambling. End of the video. Have a good one.